This week in Algebra 3, so we've got, today we're going to talk about factoring. Today is going to be a factor day, okay? Tomorrow, I shouldn't say tomorrow. Tomorrow we don't have class. Wednesday is going to be a factor day, and we start solving day. Thursday is going to be a solving day, and Friday of this week is going to be a formative day. Okay? You'll have a homework that we give you today that will also be due this week Friday. Okay? Looking ahead, then next week is that goofy half of a week, because it's literally half of a week. We got class Monday, Tuesday we don't have class, and Wednesday morning we have class but we only go until 11:30. It's a half day on Wednesday, and then Thursday you don't have school at all, and Friday you don't have school at all. Okay? So that's one of the. It's literally a half of a week.
Wait, Halloween break isn't it?
That's. But Halloween isn't until
The next week.
the next week Tuesday. So it's pre-Halloween.
Yeah. So what are the dates?
So next week, the 25 is a half day.
Yeah,
26 and 27 are off.
What is
26 is a teacher in-service day. 27 is just fall break.
Yeah, it's like might as well.
Why is
it
Because we have conferences in the afternoon. They move conferences up to like the afternoon because not every parent can come between 4 and 8 now. So they move one of the 2 fall days. Like we go. Okay. Let's put the fun in function today. All right, here we go. So today we're going to learn 4 ways to, or I shouldn't say learn. Learn is a bad choice. Fellas. I believe that I've started. Yes? Okay. 4, we're going to refresh. Refresh, I like better. 4 ways to factor. Okay? So, the first thing that you should do is you should always check for, we call it the GCF. GCF stands for greatest common factor. Something that goes into every single one of your terms. Okay? So if I'm looking at 8x squared plus 20x, the first thing that I would look at is I would look at the numbers, and I would say to myself, what is the biggest number that goes into 8 and 20? 4. 4 is the biggest number. So the number part of the GCF would be 4. Okay? Then I look at the variables. And I say to myself, self part A, if you will, do all of the terms have the same variable? Yes or no? In this case, yes. Part B, self part B, what is the smallest? Now this is where you got to kind of think inverted. What's the smallest exponent that we have of all of those same variables? X is the smallest. So x to the first is the smallest. So my GCF would be 4x. Which means I'm going to write that out in front. 4x is my GCF. Then I divide each of my terms by my GCF. 8 divided by 4 is 2. X squared divided by x is x. So I'm left with 2x. Then I go to the next one. 20 divided by 4 is 5. X divided by x makes it go away. So I'm left with 2x plus 5 instead of 5. Okay? Now, the all-important question. How do I check to make sure I GCF?
You multiply 2x plus 5 by 4x.
So distribute the 4x back in?
Yeah.
Yep, exactly. We distribute the 4x back in. 4x times 2x is 8x squared. Got it? 4x times 5 is 20x. Got it. Okay. Now, I will tell you that you should always, no matter what kind of factoring problem it is, always do that first. Because the worst case scenario, nothing happens. Okay? Best case scenario, something gets factored out and now your numbers are smaller for one of our yet to come factoring methods. Okay? And smaller numbers make it easier on us. Okay? Okay? So that's our first one. Second way is difference of perfect squares. Okay? So when you're dealing with a difference of perfect squares, you have to have a perfect square first. You have to have a perfect square second. And it has to be easy there over there, Siri. And it has to be a subtraction sign. Okay? So those three things have to happen. So in remembering perfect square numbers, talk to me. What are the perfect square numbers? Let's go smaller than 150. What's the first one? Nope. 1 is the first one. Then? 2 is not. 4 is. Then? 9 is next. 16. 27 is not. 25 is. 36 is. 49 is. 64 is. 81 is. 100 is. Now we're getting into the harder ones. Now we're getting into 121 is.
144.
144 is. That gets us up to 150. 169 would be next. 196 would be next. 225 would be next. So on and so forth. Okay? What were we doing? No, tell me what we were doing.
You multiply.
1 times 1 is 1. 2 times 2 is that. Perfect squares are the same number times itself. So that's the first 12 perfect square numbers. Okay? Alright? Now, let's get cray-cray. Okay? What is a perfect square variable? Ooh, making me think. What's a perfect square variable?
X squared.
X squared is 1.
X cubed.
X cubed is not. X to the 4th is. X to the 6th is. It's what? Even. What's even? Even exponent. It's got to have an even exponent. Okay. So numbers, and find a number that's multiplied by itself. For variables, all even exponents are perfect square variables. Okay. So, when you think of this, you think of this as 3x quantity squared minus 1 quantity squared. Okay? Where you are squaring 3x to get 9x squared, you're squaring 1 to get 1. Okay? If that's the case, then it factors to be 3x minus 1, 3x plus 1. One of them minus, one of them plus, on a perfect difference of perfect squares. Okay? My question to you is this. I'm posing lots of questions today. You guys are doing a good job of it today. In number 1, we distributed to make it, to check it. How do we check number 2? To make sure we factor right. Do what? Multiply them together. So it's a double distribute, right? Okay. So we would go 3x times 3x gets me 9x squared. We can go 3x times 1 gets me plus 3x. We go negative 1 times 3x is negative 3x. We go negative 1 times positive 1, and that can give you negative 1. What happens? Positive 3x minus 3x. They cancel each other out, leaving me with 9x squared minus. Questions on that? Okay. Then we got number 3. Our third way of 5. Today we're only going to do 4. Basic product of two binomials. Okay. There's really no set method to do this one. Okay? It's the one time in mathematics that I'm going to tell you yes and check. Okay? How you do this one, for lack of a better term, I call it the butt cheek method. Okay? 2 sets of big parentheses. Okay? Now, oops, I should move that over. Oh, I thought they were all going to come with. Instead, they're coming all separately. Okay? What 2 things multiply together to give me 2x squared? 1 and 2 would multiply together to give me 2, not 2x squared.
1x times 2x.
1x times 2x would multiply to give me 2x squared, right? Okay? So, that's the easy one to start with, especially if that's a nice prime number. I'm going to go 2x, and I'm going to go x. Okay? What 2 things multiply to give me negative 20? 5 and negative 4? Negative 5 and positive 4? Okay, what else? Two and negative 10? Negative 2 and positive 10? What else? Negative 20 and positive 1? Or negative 1 and positive 20? Right? Okay? So those 2 are, so we need to go one of those 6 pairs. So we've got some more choices here. Now, these 2 get multiplied together, and the combination of those, so we're going to add a number. We're going to add 2 numbers right in there. Okay? Those 2 get added together to give me negative 3x. For lack of a better way of saying it, okay? two numbers that are closest to one another. Okay? So I'm going to start here with positive 4 and negative 5. If I do that, here, these two get me positive 4x. These two out here give me negative 10x. What is positive 4x minus 10x? Negative 6x. Is negative 6x the same as negative 3x? No, it is not. So that is not factored. So this one does not work. Okay. Right away then, what I would do is I would switch them. Oops, I shouldn't have said that. I shouldn't have said that this one doesn't work, because I have to try it in the other form first before I can determine if it doesn't work. So we're going to go negative 5 there, and we're going to go positive 4 there. Okay? So in here in the middle, I get negative 5x. On the outside, I get positive 8x. Negative 5x plus 8x. Yep. Negative 5x plus 8x. Positive 3x. Is positive 3x the same as negative 3x? No, it is not. But it's 3, right? Okay. So what can I do then to make this one work? Just switch the signs. Yep. Okay. So if I switch these signs here to positive, here to negative, now this one gives me positive 5x. This one now gives me negative x. Positive 5x minus 8x is my negative 3x. So this one factors to be 2x plus 5 times the quantity x minus 4. Okay. Our last method that we're going to talk about today is going to be cubics. Okay. Now we're going to spend a whole slide on cubics here coming up, so I'm not going to tell you how to factor them right now, but I do want to talk a little bit about perfect cube numbers. What's the first perfect cube number? 1 is the first perfect cube number. What's the next one? 8. Next one. 9 is not a perfect cube. 27 is next. Next one. 64 is next. Next one. Big jump.
125.
125. Next one. 216. Next one. 343. 512. 512. Yep, 512. 9 is 729. 10 is 1,000. How do we come up with those? Cube the number, multiply the number by itself 3 times. Okay? 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, etc., etc., etc. Okay? What is a perfect cube variable? Be an example of a perfect cube variable. X cubed. X cubed. Give me another one. X to the 5th is not.
X to the 6th.
X to the 6th is, yes. X to the 9th is. Exponents are divisible by 3. Yep. Okay? Alright? And we'll get to that here in a minute. Okay? So, when we say factor completely, that means that you have to factor until you cannot factor anymore. Okay? So you might have to do a combination of 2 or more of those that we just did. Okay? GCF, difference of perfect squares, basic trinomials, and cubics. Okay? So you might have to do a combination of those. And you're going to factor until you can't factor anymore. It's kind of like reducing a fraction. Okay? Try to think of a good fraction. 56 over 64. Okay? Alright? I could reduce those both by 2, right? But that wouldn't be all the way. I could reduce them both by 4, but that wouldn't be all the way. We gotta go all the way. Okay? So, does 98, or is 98 divisible by 14? By 7? 7 times, right? Okay. So because we could divide them both by 7, right? But you're saying we can divide them both by 14, right? Okay. So we can divide here by 14. We can divide here by 14. Do we have variables in both? No. So then 14 is my greatest common factor, and I'm left with then 7x minus 1. 7 and 1 don't have any common factors. Neither one has an x in it, or both of them don't have an x in it, I should say. So I'm left with that. In part B, what is my greatest common factor? Sorry, I was just checking to make sure there wasn't a C on this one. Greatest common factor is what? 2? Is 2 my greatest common factor? 2x is my greatest common factor. What's left over? 6x squared plus 11x plus 4. Okay. Now I've got to look at just that, and I have to determine if that is factorable or not. Okay. 6x squared, what multiplies together to be 6x squared? 2x and 3x? Or 1x and 6x, right? So we got that one if neither one of these work. Okay? what multiplies together to be 4? 2 and 2 or 4 and 1? Or negatives. Okay? All right. So let's go 2 and 2. So if I do 2 and 2, I get 6x and 4x, right? Either both positive or both negative. Doesn't make 11, right? Okay, so that's not going to work. What's my other choice? 1 and 4. Do you want the 1 first or do you want the 4 first? The 1 first? Okay. If I do that, then I've got 3x and I've got 8x. Together, those give me 11x, which is what I want, right? Both positives or both negatives, or one of each? Both positive, because I want it to be positive 11. Okay. So this factors to be 2x times 2x plus 1 times 3x plus 4. Yeah. Good times. You try those two. Greatest common factor would be 5g cubed. That would leave me with g squared plus 16. Can g squared plus 16 be factored? Why? How? Because g squared is a perfect square, 16 is a perfect square, but what's the kicker? Not a subtraction sign. So it can't do it different a perfect square. Yep, can't do it that way. So this is actually as far factored as it can go. Greatest common factor over here is 3x. Leaves me with, oops, break some green on this slide. Leaves me with 25x squared plus 10x plus 1, which that then is 5x plus 1 and 5x plus 1. So here, this one would factor all the way down to be that, or I would also accept because there are two of the same factors, we could square it. Okay. Let's talk cubics. I'll give you a few minutes to write these cubic formulas down. You will not, repeat, not be given these formulas. You need to memorize them. Okay? I'm not joking. It's a college class. Yep. I don't memorize the formulas. I memorize the path. But I'll talk about that after you get it written down. So how I attack these problems, okay, is first I determine what I am cubing. Remember, we gave you a list of cubic numbers earlier today. And what's a cubic variable again? Exponent is a multiple of 3 or divisible by 3. So I determine what I'm cubing, in both spots. That gives me my A and my B. Okay? Then, my first set of parentheses here is just whatever I'm cubing with whatever operation I'm doing and whatever I'm cubing. So I just write it A plus B or A minus B. Okay? Then, over here, I square the first one that I'm cubing. I square the second one that I'm cubing. Those are my bookends of my trinomial. Okay? And in the middle, I just multiply them both together and I invert the sign. So if it's minus in the original problem, that sign is plus, and vice versa. Okay? Memorize the pattern, not all of these letters. Okay? Okay? With that being said, the nice thing about factoring by cubing is this trinomial that you end up with here is not factorable after you get done. Okay? So you don't have to go through that one and try and factor that trinomial even more. It is an unfactorable, it is a prime trinomial. Okay? Okay? Let's put it to work here now. Okay? So we've got 27x cubed plus 125. First question you ask yourself, because you see the cubic variable, you should automatically be thinking cubic formula. Is 27 on our cubics list? Yes, it is. It's what cubed? 3 cubed. 3 cubed. Is 125 on our cubics list?
Yeah.
Yes, it's what cubed?
5.
It's 5 cubed. Okay? So this is really 3x cubed plus 5 cubed. With me? Okay? So my first set of parentheses is just going to be 3x plus 5. See it? Whatever I'm cubing, whatever the operation is, whatever I'm cubing. Okay? My second set of parentheses, I'm going to square that term. 3x times 3x.
9x squared.
9x squared. I'm going to square that term. 5 times 5.
25.
25. Those are the bookends. Those will always be positive. Because you're squaring. Okay? Then, I take those two and I multiply them together. 3x times 5. 15x. Since this was plus here and here, what's going to go in this gap?
Minus.
Minus. We switch that sign. And that's it. That trinomial that we just created is not factorable. Okay? Questions on that? While I hand out this week's homework, you try to factor that one completely. I'm going to factor out a -2. d squared. If I do that, then I'm left with positive 8 d to, oops, I almost put d to the 5th. Positive 8d cubed minus 1. Does everybody agree with me on that? Yeah. What have I done?
Math.
Well, I've done that, but I've created a positive lead coefficient. 2d squared divided by negative 2d squared. Yep. Okay. Is this a perfect cube? Yes, it is. Is this a perfect cube?
Yeah.
Yes, it is. So this is going to be 2d cubed, and this is going to be 1 cubed. So this negative 2d squared comes along for the ride. It's kind of like one of those Amora fish that goes along with the sharks. Then we've got 2d minus 1, and we've got 4d squared plus 2d plus 1. Yeah, buddy? Okay.